characteristics of cloud also. So in this chapter, we want to explain the introduction to compute visualization. Visualization is one of the technologies or the most important technology that the cloud computing is built on. So we are going to discuss this and we are going to see how this technology is related to clouds. So of course, the first version of cloud computing, that's cloud 1.0, is focused basically on visualization, which today has become the foundation of cloud computing. On it, the other technologies of on-demand services, pay-as-you-go, all these are built on the visualization technology of the cloud. So the objectives for this chapter basically is to be able to describe what visualization is and to understand the differences between visualization and cloud computing. To understand KVM technology. KVM is one of the visualization technology or hypervisors. Last but not least, we will also discuss about understanding Huawei's Fusion Sphere visualization solution. The Fusion Sphere is the Huawei's approach to virtual machine monitors or VMM. So introduction to visualization. How is a virtual machine created? That's the question that everybody wants to find out, basically. If you are starting this chapter at the beginning, you will want to know how is virtual machine is created. So virtual machine is a shared technology which is built on what is called physical machine. Physical machine is the computer that you use physically, and the virtual machine is the machine or a replica of the computer that is being created on the physical machine. So how is this done? So let's go through it and see how it's done. So we have the physical machine. Yeah, on the screen, you can see the physical machine there. Yeah. So on it, we can create different virtual machines to share the resources. The most important resources in the visualization technology to be shared are the CPU, the memory, and of course the input-output devices. So these are the important things. In the past, in other courses, probably you have come across some of the visualization technology like the VMware, Oracle VMware, and of course the Xen or Zen. Some pronounce it as Zen. It's one of the technologies. And of course the VMM, KVM also. KVM is built basically based on the Linux machine. How this started? It started far back, visualization or virtual machine creation. The idea itself is actually an old idea, started far back in 1964. And this began with IBM. IBM are the International Business Machine Company. They began this visualization exploration on mainframe computers far back in 64. And then they launched the virtual machines that are running on mainframe computers in 1972. By 1990, VMware, which is of course one of the popular virtual machine monitors that we also use even now, they now launched their own version, which runs on x86 based on visualization products. In 2007, HP also tried to explore this visualization technology. So they launched HP UX Integrity VMs. By 2028, Microsoft added Hyper-V, Hyper-V in Windows Server 2008 R2. Linux Container, which is also called LXC, was launched in 2008 also. The same 2008, we have um, support for KVM for the visualization option was also launched. 2011, HP they introduced uh, another version of visualization technology, which is based on Open Visualization Alliance. This is to accelerate the KVM adoption. So this collaboration is between IBM, HP, and Red Hat. Buka was launched in 2013, and Rocket was launched in 2014. So basically, these are some of the the timeline of history or development of visualization technology that was recorded, basically. Of course, I'm not so much interested in the history, so I just try to read it through for you. There wasn't much to explain for the history, so let's go to the important concepts. So we have a physical server. So this is the concept. We have a physical server. On it, we have a host machine. On the host machine, you can install any operating system, Windows, Linux, or Mac. This is called host operating system, host. In the host, or in the operating system, you can as well install different applications, Microsoft Word, PDF readers, music streaming applications, or you can install browsers also. So all these are applications that runs in your operating system. So this is how the normal, how the normal machine looks like. Okay, so we have the host machine. In it, you can have the host operating system, and on the host operating system, maybe it's a Windows operating system, you can install applications. But then we have the virtual machine. On the virtual machine, this is what happened on the physical machine. That's, for example, the laptop you are using or the desktop you are using. Okay, so on the virtual machine, this is how it looks like. You have your host machine. On the host machine, you can install a virtual machine monitor, which is also called VMM or hypervisors. Good example of VMMs or hypervisors is the Oracle VMware, right? Mostly we have them that we use in other labs. And you see, yeah, Oracle VirtualBox and VMware Workstation. So these are some of the virtual machine monitors, which are also called VMMs. So we have the Oracle VirtualBox or VMware. So I go back to the slides. So this is basically installed on the host machine on your computer directly. So after installing the VMware or any hypervisor, then you can install a guest machine. Okay, a guest machine is the virtual machine VM. Note that there's difference between VMM and VM. VMM is the virtual machine monitor. A good example of VMM is the virtual box and the virtual and the VMware or Zen. Okay. Then the guest machine is the machine that you create with your virtual box, for example. So if you create a machine, it's called a guest machine. That's the VM. Okay, so you can see this machine, a good example, VM. Okay, so you have to create this on the hypervisor. So after creating this, then you create the guest or you install the guest operating system. So in your virtual machine, you can decide to install any machine because any operating system because already is a replica of your original device or the host machine. So it's running on the host machine, sharing the same resources with the home host machine. The resources mostly shared the input output devices, the CPU, and of course the memory. Then the applications, you can install different applications on the virtual machine uh, guest operating system. So this is basically the important things that you need to know in visualization. Host machine is the bare machine that you have. The virtual machine monitor or with the hypervisor is the monitor, I mean the VMM that you will need to install before you start creating your virtual machines, which is guest machine. And then in the virtual machine, you now need to install an operating system. It could be a Windows or a Linux. And in it, you can install your applications. So this is how the virtual machine basically works or looks like. So the host machine is a physical machine, while the guest machine is the virtual machine. So this is another important difference. The different types of visualization. Visualization technology works in two ways. That's what we call type 1 and type 2. Type 1 is bare metal visualization. Actually, the previous slide we just explained now, replicates more of type 1, okay? Where you have the hardware, um, which is the physical machine. Then you have your VMM installed on the hardware, okay? And with the VMM, you can create guest machines, which is the VMs. You have the VMs created on the guest machine in order to share the resources of the hardware. Okay. And in the VMM, you can now start creating or installing your operating system, be it Windows or Linux. And in the operating system, you now create or install your applications. So this is a typical bare metal visualization. It's called bare metal because the virtual machine monitor is installed directly on the metal, which is on the device that you have directly. Okay, so this is the commonest one. So let's look at type 2. Type 2 is hosted visualization. In hosted visualization, on your hardware device or in your normal laptop on desktop, you already have an operating system installed, like what I have now. I have an operating system, which is Windows, installed already. Okay, then I now install the virtual box in my operating system. After that, the virtual box is residing on the host's operating system together with other applications. There's no issue with that. So in the virtual box or in the VMware or in the VMM, as using the general name, you can install or create your virtual machines. So we created virtual machines and in it we can create operating systems, which are now guest operating systems because they are residing inside the guest machine, which is the VM. And then you have the applications installed in them. So this is type 2. In type 2, the VMM is installed on the host operating system, while in type 1, we don't actually have a host operating system. You have your machine, and then you simply install your virtual machine monitor, and in it you create your virtual machines, and then guest operating systems installed and the applications installed. So these are the two different types of virtualization technology that we have. Any question?
Clear, Doctor.
It's clear. Okay. The characteristics of visualization. Number one is partition. So we have the host operating the host machine, okay, which is the physical machine. In the physical machine, you have your processor and you have your memory, the memory of the basically of the physical machine. These are common resources that we want to create virtual machines to share. So we have to partition the operating system. We have to partition this to create different virtual machines, which they are going to share the same resources of the physical machine. So for example, you have, let's say you have 500 gig. Okay, this 500 gig, you can create 3 different virtual machines that will share this. So this is partition basically. So you partition the hard disk to install this using the visualization technology or using the VMM, which is the virtual machine monitor or hypervisors. So this is called partitioning. It means that you partitioned and created similar machines on the same physical machine. The second characteristic is isolation or isolated. Now, this is the thing. For example, in this case, we created 3 different machines. If one of the machines crashed, because it's completely isolated from others, there will be no issue. The remaining 2 will still be in a good shape. They will be working okay because actually the virtual machines are always isolated from each other. Another way that you will understand the concept of isolation is if you create one virtual machine, create a second virtual machine. Then you input or you store information in the first virtual machine. If you open the second virtual machine, you are not going to see that information. And you cannot access the information that are in the first virtual machine. Why? Because they are actually completely isolated from each other. So this is another way we can explain the concept of isolation. Then the next one in encapsulation. Encapsulation helps us to understand that after creating a virtual machine and storing it, is encapsulated and stored on a hard drive, okay, on a section of hard drive. So if you can identify these files, you will see that they are encapsulated. They look like if they are encrypted, okay? So it means that they have been secured and kept securely. Encapsulation helps you also to move these files. If you can move the complete files of a virtual machine created, you can move it to another virtual machine and you can install it and it works. This is also what makes it to be what? Independent. Okay, they are independent of that's and I've now moved to the top 4th characteristics. Independent means that the virtual machines are independent of the physical machine. So it means that I can actually copy a virtual machine and put it on another physical physical machine and it will still work. All I need to have is to have the same hypervisor, VMM. Yeah, VMM. That's if I have a virtual box here, I can have a virtual box on another machine. If I create the virtual machine in the virtual box of this, after I finish all my installations, I can actually copy it. If I copy the virtual machine, I can transfer it to the next computer where I have my second virtual box. I can now install it in it, and then I will see all the contents that I created in this virtual machine. They will still be here and they can work. Now, this is the concept that we use sometimes in some of the labs. If we realize that the student find it difficult to do some installation, so we simply create a virtual machine and finish all our installations. Once we finish, we upload the virtual machine on the Blackboard and we ask the student to download it. When you download it, you already have VirtualBox or VMware on the machine that you are going to use. So we just simply ask you to import it, and then you have all your installations in it. You just follow the instructions to do your lab. So this is what makes it to be independent. It's not that if you create the virtual machine on one machine, it will not work in another. No, that's not. It's actually independent of the physical machine that you created. So this is the next characteristics. So these are the important characteristics: partitioning, isolation, encapsulation, and independence. So as I mentioned from the beginning, that the shared resources that virtual machines actually use are CPU, memory, and input-output. So all our discussion will be surrounded around this. So for CPU visualization, there are two types. There's what is called full visualization and para visualization. So you have your hardware, okay? We have the hardware. On the hardware, we have the hypervisor, and on the hypervisor, we have the guest operating system installed in it. And then we have Ring 2, where you can have any other thing. And of course, we have the um, Ring 3, where you have your applications. Someone will ask, what is there in Ring 2? In Ring 2, mostly we have libraries. Mostly we have libraries. If you are using Java, you have the libraries. So you can have any other thing in Ring 2. However, the important thing to explain here is if you are running an application on full visualization, this is what happens. There are two types of instructions that the applications can actually handle. You can have privilege and normal instructions. If it's a privilege instruction, the application can send the instruction directly to the processor and the processor can process it directly. Okay, simply convert it to 0 and 1s and then process it. And then send back the information directly. Privilege instructions for users. Okay, but then you can have normal instructions that have to go through from the application to the guest operating system, and the kernel instruction will handle it and send it to the hypervisor, and hypervisor will process it and send it to the hardware. Okay, and the hardware
Doctor,
will process. Now,
sorry for distract you, Doctor, but in Ring 2, I
yes,
don't get the point here.
oh
So
yeah,
you said we can have any other another things like uh, uh, and can you give an example?
yeah, I just gave example libraries. Okay, so for example, if you have Python, okay, Python is your application. The libraries of Python can reside in this Ring 2.
Uh-huh. Okay, okay.
Okay, yeah, so this is a good example. So any other thing aside from applications actually can reside in this. It's just an empty space where it can accommodate other applications that are not necessarily needed directly by the user. Okay. So if the user wants it, need to call it from ring 2, then it goes to the application and the user can simply use it. Okay. So this is called full visualization. In this case, for normal instructions, the applications have to send the instructions to the guest operating system, and then the guest operating system will have to send it to this hypervisor, which is like your VMware or your virtual box. Okay, so the hypervisor will send the instructions to the CPU in this case, okay, which is the hardware. Okay, so the CPU will process this instruction and then it goes back the same way it comes and sent back to the application. So this is called full visualization. The main difference between full visualization and para-visualization is just in terms of the technology used. The guest operating system uses what is called para-visualization technology, okay, where it uses what is called hypercall to send the information to the hypervisor, and then the hypervisor uses also another hypercall to the CPU. Okay, the CPU is the hardware. So the CPU will process this instruction and then send it back as it comes using the hypercall. So this is called para-visualization. Other differences, we will explain them as we proceed in the slides. However, the privileged information follows the same way. Okay, so applications can send privileged information directly to the hardware, which is the CPU, and the CPU can process it and then send it back. So it doesn't have to go through the complete rings from 0 to 3. Okay, it can actually send privileged information or information that are urgent, okay, and need to be executed immediately. So we go to the second one, which is memory. As you remember, I said the shared information or resources that the virtual machines are actually sharing with the physical machine are CPU, memory, and the input-output devices. Okay, so we just explained the CPU. We are going to memory visualization. The memory can be shared also with the VMwares. Okay, so you have the hosts. The host is your main computer. So you have the host memory. Host memory will now be divided into the number of virtual machines that you are using. If you have let's say 8 gig memory, okay, you have 4 virtual machines. Four virtual machines can actually share, maybe this can take 1 gig, this can take another 1 gig, this can take another 1 gig, and this can take another 1 gig, making 4 gigs of memory shared for the virtual machines. And the physical machine can still use the remaining 4 gig of memory space. So this is one way that I can explain it. But let me see if I can use a drone. Okay. So now this is the memory of your physical machine. Let's say this is your laptop. This is your laptop memory. Oh, this mouse is going crazy today. Laptop memory. and you created 4 virtual machines on it. Okay, virtual machine. Yeah, the memory is numbered from 0 upward, so you can have this space is 0, 1, 2, 3, 4, and then 5. And of course, it goes like this. Okay, so now this is how it's divided. So let's say this section of the memory is where VM1 is using. VM2 will be using this section 1. VM3 is using this section. VM4 is using this section. So all the other remaining memory space remain actually vacant, basically. So when you have this, on the virtual machine itself, if you open your virtual machine, okay, maybe whatever section of memory that is being shared here with VM1 is what you will have. If it is if it's just 1 gig that is assigned to it, yeah, you will see 1 gig. But again, that 1 gig you can also divide it into, okay, you can divide it into spaces. Yeah, so you can divide it into spaces. So basically, this is what happened. If I go back to my example, if it is 8 gig and 1 gig is assigned, this is the only space that this virtual machine is using from the memory. And virtual machine 2 is using only the space of the memory. Virtual machine 3 is using space number 3 in the memory. And of course, virtual machine 4 is using space number 3. So this is how it looks like. But if you go into the virtual machine, okay, whatever slide of space that is given here is what you will see here. And then, of course, you can slide it further from the virtual machine and you will see the spaces as done here. I don't know if this gives some clarity of how visualization looks like for the memory. Ali and Mohammed.
والله دكتور, honestly, يعني I don't understand exactly what we have to understand from this slide. يعني I feel I'm confused here.
Okay, okay. Yeah.
It's like you are explaining how the CPU of our physical machine work with the virtual machine, right?
Yes. I'm explaining not the CPU now, but now we are talking about the memory. Okay. I'm
Okay.
explaining the memory, how the memory is shared of your physical machine together with the virtual machines. But because you know that how many virtual machines you create, they are still sharing the same memory of your physical machine.
Okay, let me make it easier. Maybe you are trying to explain when we have a virtual machine box or VMware. Okay, and
Exactly.
inside it we have many uh, yeah, more than one
Virtual
like
machine.
virtual machine. Yes,
Yes,
like we
so
have
like
one.
this,
We
these
have
are the virtual machines that you just mentioned. 1, 2, 3, 4, for example. You created 4 virtual machines. Yes,
uh,
continue.
okay, and every يعني like we have Linux, Windows Linux, we have Windows 2012, like different kind of virtual machine. You mean?
Yes. So
Ah,
those ones that you mentioned, okay,
okay.
uh, Windows, Linux, okay,
Yeah.
these are like the operating systems installed in the virtual machines.
Yeah. Yes. 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 Okay.
These are called guest operating system, guest OS, as we mentioned in the previous slides. Okay, these are the guest OS. Okay, continue
Okay. That's all what I'm trying to
to
to explain.
understand.
What I have to
Okay,
yeah. What I have to understand.
so now I will explain further. Okay, you
Okay.
actually get the concept. Okay, the concept is now look at this line. This line shows that what we have here is the host memory. What we have up there is the virtual machine memory. Okay,
Okay.
but actually, all the virtual machines that you create on your device, they are still sharing the same memory of your computer.
Yes.
Okay, so if your computer has 8 gig memory only, for example, if it is 8 gig memory, it means that the first virtual machine will take a small slice of the 8 gig. Let's say 1 gig is assigned to it. And the second one is also taking 1 gig of the memory, another 1 gig of the memory, another 1 gig of the memory. So you have this one using 1 gig, 1 gig, 1 gig, 1 gig. So this is 4 gig of the memory. Your physical machine, that's your computer, still have 4 gig of memory space to play around with. This is just an example, okay? So, but
Okay.
again, on the memory itself, memory, you took with me already forensic, right?
Yes.
Exactly. So memory is divided into what we call clusters and
Yes.
sectors. Okay, clusters and sectors. So basically, this is the first sector of the memory, and this sector is only assigned, for example, to VM1. So VM1 is only using this portion, and maybe this portion is only 1 gig. VM2 is using sector or probably cluster 1. VM3 is using sector 2, and VM4 is using this. So all what you do here on the virtual machine, it only occupies this space of the actual physical memory of your machine. Do you understand now?
Yes. 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 No, I get the point. No.
Yeah.
Thank you.
Okay. So now number three. Number three is input-output visualization. There isn't much to explain here. Input-output visualization is the visualization of other input-output devices on your computer, like keyboard and the mouse. Okay, keyboard and mouse uses full visualization concept. Para-visualization of input-output devices works with what we call front-end and back-end input-output. Okay, so input-output uh, basically uses two types: the full visualization, which is also called emulation, and para-visualization, which uses front end and back end visualization. A good example of an input device on the computer that uses this para-visualization is the NIC. The NIC is the network interface card that basically enabled Wi-Fi that you have to access the Wi-Fi on the on any wireless network. Okay, so we have other examples, but these are some of the best examples that we can give. The hard disk and the NIC, network interface card. So cloud computing and visualization. Visualization is the same concept that cloud computing adopted and is using. But in this case, it uses this concept in large scale. Okay, so you can have data centers, and the data centers, you can have virtual machines, which basically give or assign resources to users. And these resources come in different types. It could be storage resources based on infrastructure as a service, or it can be platform for development of programs or shared software applications for which the user will simply use and then pay based on usage. So this is the same concept that cloud computing is using, similar concept. So you can have your the virtualization technology, you have your physical machine, and then you have created virtual machines managed by the virtual machine monitors or VMM or hypervisors. So the same concepts cloud computing actually applies. So you can have different applications, okay, which are now the services. And through visualization, these services can be assigned to users for use. So visualization technology, as I said, applies to virtual CPU visualization, memory visualization, and then input-output visualization. There are two types, the open source and the closed source version. For open source, a good example of virtual machine monitors or hypervisors are KVM and Zen. Some say it's Zen, the pronunciation. Some say Xen. I don't know which one is the correct one. So basically, I use Zen. So these are the open source version. The closed source version, Hyper-V and VMware. And then the Huawei's version is Fusion Sphere. I'll ask you, the virtual box and the VMware, where do you place this? Open source or closed source?
Sorry, Doctor, what is your question?
The virtual box
Yes.
and the VMware, we use these ones in the
Open
college.
source.
Open source, yeah, we
Why do you say it's open source?
because it is I think because it's free and available to use.
Yeah. Free and available. Mm, okay, Muhammad,
Yes, Professor.
do you think it's open source?
The virtualization.
Yeah, the virtual machine monitors that we normally use in the college, like the virtual box and the.
I think it is open. Actually, yeah, it is open source, no?
Why did you say it's open source?
Because I don't know. Because the Hyper-V, for example, the one over there is for Microsoft, so that's closed source. But I haven't heard about the other one being closed source. It's an assumption. I don't actually have facts.
Okay, now let's go back to the basic definition of what is called open source and what is called closed source.
I know it is open source. It is usually when it's open to the community, like anyone can contribute towards the work itself.
The development of the code.
Or they
Basically.
could actually take the original and modify it on their own, which is what Linux is mainly like.
Exactly. So can you do this on Can you do modification? Let's go. I have them on my screen. Okay, this is VirtualBox.
Oh yeah, it's
This is
Oracle. Never mind.
VMware.
Yeah, it's Oracle. Never mind.
So actually they are closed source because the basic definition is not because they are free to download. No, actually it's because the source codes are open for contribution from other developers. Other developers can be able to modify or can add some new features, okay, through the coding. So that's what makes actually software to be open source. A closed source is you don't have access to the codes. They will only give you the installation executable file, and then you simply install it, and then that's it. You don't have any permission to be able to modify and add new features to it. Okay, so all this actually that's what makes them to be closed source. So for me, I put um, the Oracle VirtualBox and the VMware to be closed source. Okay. The Zen and the KVM. KVM is based on kernels. Kernel virtual machine or virtual mode it runs based on Linux, and Linux we know is open source. So it's like saying Microsoft and Linux. Microsoft Windows is closed source. We don't have access to the codes. But Linux, we have actually access to the code, and that's why you have Linux distros or distributions. Different distributions of Linux are available. You can have a Kali, you can have the Ubuntu. All these are companies that modify the codes to suit their different features, basically. So this is the general idea. So let's look at Zen and KVM. For Zen, it's normally installed on the hardware, via hardware, okay, directly. And then you can have your different virtual machines. So, but additional feature is that it uses the concept of front ends concept for the virtual machines, and then it has also back ends for the virtual machines that interacts directly with the hardware drivers. So this concept is directly what we have as, is it type 1 or type 2 visualization? This one, the first one, for Zen. I don't know if you can remember.
It's full virtualization or
Full visualization. You will see.
I think type 1.
Yeah, it's type 1. Okay, it's bare metal visualization is type 1. Okay, where you have the hardware and you have the hypervisor installed on it. So the hypervisor we're using here is the Zen. So the Zen is the one that is installed on the hardware, and then you create your virtual machines on it. So it's type 1.
Victor, can you again
Yeah, so
explain the concept?
yeah, the concept is if your hypervisor is installed directly on the machine,
Okay.
it's type 1. It's type 1. Okay. But if you already have an operating system on the machine, and then you install your hypervisor on the operating system, like what I have here now. I have my computer, which is the hardware, okay? And I already have Windows installed on my computer, okay? Which is now the host operating system, okay? And then I install a hypervisor on it. So the hypervisor is not directly on my machine, rather is on top of the operating system. So in this case, this is type 2. The KVM is the hypervisor in this case. Okay, is installed on a Linux. So like for example, what happened in this second case, this is type 2, okay? You have your computer, this is the hardware, and you already installed a host operating system, which is the Linux. So inside the Linux, you install the KVM. This is the hypervisor or guest operating system. Okay, so in the guest operating system, you can, sorry, this is the hardware, okay? This is the host operating system, and this is the VMM, yeah, virtual machine monitor. In it, you now create your guest operating systems. So this is second type. So if I go back to that slide where it's explained type 1 and type 2. So this is it, type 2. You have your hardware, you create or install your operating system. In that previous slide, it shows that the guest or the host operating system is Linux. So they install Linux before they install the KVM. The KVM is the VMM, that's the hypervisor. And then they created the virtual machines on the KVM. So this is type 2. In other words, look at type 1, look at type 2. If the VMM is directly on the hardware, it's type 1. The VMM here is not directly on the hardware. There's already an existing operating system that is installed. And then the VMM is installed on it. So this is basically type 2.
Yes, okay.
So just to differentiate easily, if the VMM is directly on the hardware, it's type 1. If it is not directly on the hardware, it's type 2. So the concentration is the virtualization technology, which is the VMM. So I go back to the previous slides, and then you can see it. This is your hardware. This is the VMM. Then that's the visualization technology. It's installed directly on the hardware. This is type 1. Okay. The other visualization technology, KVM, here, it works with Linux. Okay. So after they have the hardware, they have to they install the Linux and they install the KVM in it. So that means that the VMM, which is the KVM, is not directly on the hardware here. It's not. So now we are in slide number 19. How many hours have we spent? Almost 1 hour. Yeah, that's good. So let's go. Hopefully we finish today, this slide also. So introduction to KVM. Now we want to discuss about KVM. So far, up to this point, what did we know about KVM? We know, number one, we know that KVM is a visualization technology. Number two, we know that KVM is also a hypervisor, or what we call virtual machine monitor, or VMM. Number two, we know that it basically works with Linux operating system. Sorry, that's number three. Number three, it works with Linux operating system. Why? Because it's kernel-based, okay? Actually, the full meaning of KVM is kernel-based virtual mode or virtual monitor. Kernel-based virtual monitor or virtual mode. So with this information, we now know that KVM is open source type. So let's go and see what we have here. So we have our physical machine. Okay. This is our physical machine. In the physical machine, we have the shared resources, that is the CPU, the memory, and of course the input-output devices. For us to use the KVM, we will need a Linux because it's Linux based. Okay, so we install our Linux and then we install our KVM, which is now the VMM or the virtual machine monitor that is to be used on it. Now, this is the thing. Kernel based means that it can interact with the kernel, and the kernel is the heart of the operating system. And it runs in the kernel mode. Okay, so if you go back to refresh a little about Linux operating system, you realize that in Linux, there's what we call the user space, the kernel space, and the guest. Okay, so if we were to create the virtual machines, we will need what is called KEMO. KEMO is the manager of virtual machines in KVMs. Okay, so you can create virtual machines after installing KEMO in KVM. So we have the guest operating system, okay, then the libraries or binaries and the applications. Now, Ali, do you remember I give you example that in the ring 2 you can have libraries?
Yes.
Because so this is an example again, okay? So you can have binaries or libraries. Previously, it was not written. It just said application, and they left this place empty, and then they said operating system guest operating system. So now they give the example libraries. They reside basically in ring 2. So then you have the KEMO, that's the monitor, the manager that manages operating systems or guest operating systems in KVMs. So this is how it works. Now, what can we do? What can we use the KEMO for? We can use the KEMO to pause an operating system. Okay, if the operating system is running, we want to pause it, we can pause it. And we can actually cancel or delete an operating system from it. This is the management. So it's used to manage the operating systems. So you can have the KEMO where you can pause operating system, install any one, or simply delete the operating system depending on which operation you want to use it for, basically. So these are the important things that I think you need to know about this. Other things are familiar things, libraries residing in ring 2, and applications at the top level, ring 3. This is the architecture of the KVM. Okay, we already know now that the KVM is Linux based and is kernel based. Anytime you hear the word kernel, Linux operating system is the best example of operating system that works with kernels. Okay, so the kernels indicate that it's Linux based. So KVM works in this. Okay, so you have your KEMO, and then you have KEMO that will be you have your operating systems in the KEMO, managing the KEMO. But now we want to introduce a new tool that also manages applications that runs on the KVM. This is called libvirt. Libvirt is a management tool. Okay, there are other operations that you want to make. You on the KVM, you will need the libvirt. Libvirt, you can have other tools like Vesh, Manager, Viewer, Virt installer, and others. Okay, so libvirt is a management tool that you can use to manage all these other applications that will run on the KVM. This is the typical architecture of the KVM. So in it, you have the main operating system residing on the hardware, and then the KVM, and then the KMO. The KMO manages the guest operating systems for creating operating systems, for pausing, for deleting. And then you have the libvirt that manages other tools that works with the KVM. Okay, example of the other tools: Vash, Manager, VAT Viewer, VAT Install, and others. Any question? Any question?
Thank you, Doctor.
So let's take a step further. A step further. Okay, so you have the libvirt. The libvirt, as we mentioned, is a management tool for KVM. Okay, so you have your Linux, which is the host, Linux host, and you have your hypervisor. The hypervisor is the KVM. Okay, hypervisor and VMM are the same, virtual machine monitors. Any word you use is okay. Okay, in it we create our guest operating systems, the VMs. In between, we have the libvirt that manages other tools that will run on the KVM. So this is the best architecture that you can see. Explain how the libvirt is actually managing the tools that we mentioned earlier in the previous slides. So in terms of the input-output process, in terms of the input-output process of KVM, we have the default. Okay, in the default, we have the guest operating system. The guest operating system, another word for it is the virtual machine that you just created on the VM or on the KVM. Okay, the KVM is the hypervisor or the virtual machine manager, and you have your hardware, which is your computer, where you created all the virtual machines. But of course, being a type 2 visualization technology, physical machine have an existing operating system, which is the Linux, and it is on the Linux that you created the KVM, and in the KVM you created the guest operating system. Now, this is the thing. If you have any application running on the virtual machine, that's the guest operating system. The essence is that any application on this virtual machine need to send instructions to the hardware for execution. Where is the hardware? The physical hardware is there, the last one. So from here, you need to send instructions, physical hardware, then the physical hardware can process the instructions and then return it back to the guest operating system and, of course, to the application. This is what happened. So if you are using KVM input-output process, by default, these are the steps that you need, that the instruction need to follow for it to be executed on the physical machine. The first thing is the guest operating system will send the instruction to the device driver. Okay, that's step one. Step two, the driver will send the instruction to what is called input-output trap. Trap code basically is a trap that traps the instructions sent by the driver, which is coming from the guest operating system. So the trap code running on the KVM will receive the instructions. Okay, so the instructions will now be sent to what is called input-output shared page. Okay, at the same time when this incident happened, a notification will be sent by the trap code, the KMO. We already know what KMO is. It's an emulator. Okay? The KVM trap code will send a notification to KMO telling KMO that I just send an instruction to the share page. Can you please keep it? Can you please take it? So the KMO will check the share page and take the instruction. That's step four. So simply the KMO takes the instruction from the shared page, or let's say the shared page send the instruction to the KMO and then it receives it. Without the KVM trap code sending this notification, the KMO cannot be able to accept the instruction sent through the share page. So, but because it has been notified, it will simply pick the instruction and then the KMO, which is an emulation code, will send this instruction to the device driver in the Linux operating system, which in turn send the instruction to the hardware. Okay, then the hardware, this is actually the main hardware where you have your CPU, the physical CPU, the physical memory, or the physical input-output devices. Okay, so they will simply process this instruction and then send it back to the KMO, and then KMO will have to send this instruction to the share page. By so doing, the KMO also need to send a notification immediately to the trap code in the KVM, telling the KVM that I just sent back another instruction to the shared page. So the trap code will simply have to check the input-output shared page and pick the instruction from there. That's step 8, and then send it back to the device driver, step 9, and then this instruction will be shared with the guest operating system and to the application in step 10. Do you understand?
Victor, well, here I'm confused a little bit.
Okay, I will play it again.
Yeah, briefly, if you can.
Yes, sure. It's very important I explain it once again because the next page or the next slide is also similar. So if we go to the next slide, it will be easy for us to understand.
Okay.
Okay. So now, most of the information on this slide, we already know it. We know what a KMO is in KVM. I explained it previously. What we don't know maybe is the share page. The share page is simply a container that receives information from trap code. Okay, and keep the instruction until the KMO picks the instruction from it. We know about Linux kernel, and we know about physical hardware. Physical hardwares are the input-output devices, the memory, and the CPU, which are shared resources that the virtual machine monitor is using to share with the virtual machines created. Okay? Guest operating system is the operating system that you install on the VM. So we know all this.
Yes.
Now, the next thing is to explain what happens if you have your virtual machine, if you are working on your virtual machine, how is this instruction executed? That's the next question. For example, we give you a lab. In the lab exercise, you have your virtual box and you created a virtual machine. In it, you install a Linux operating system. So in the Linux operating system, you are writing codes now. You write a program, okay, for example. So after you write a program and you try to run this program, what happened? Okay, so now this is what happened, okay? The Linux operating system in your virtual box is the guest operating system. This instruction will be sent by the VirtualBox to the device driver. The device driver in turn sends the instruction to input-output trap code in the VM, okay, or in the KVM, which is, of course, the hypervisor. So the hypervisor will send it to a shared page. A shared page, as the name goes, is a place where instructions are shared. That's why it's called shared page. Okay, instructions are shared between the KVM and the KMO. Okay, so the moment the input-output trap code send the instruction to the peer page, they need to notify the KMO. So this is the notification. That's step 3. Trap code send the instruction to the shared page, and at the same time send a notification to the KMO, telling KMO that I have sent the instruction to the shared page. Can you please pick it? So the KMO will simply request for the information from the shared page. So the instruction will simply go to the KMO, okay? And the KMO in turns send the instruction to the device driver. That's step 5. The device driver will send it to the physical machine. That's where your processor, the memory, or the input-output device are, and they will simply execute the instruction and send it back to the KMO, and the KMO will also send it back to the share page in step 7. Okay, so basically what happened is the moment the KMO sent the information to the shared page, the KMO also in turn had to notify the KVM trap code that I have sent now the information or instruction back to the share page. Can you please pick it? So in step 8, trap code will pick the instruction from the share page and then in turn send it back to the device driver, which is now sent back to the virtual machine that you are using. Then you will now see the output of your program showing.
I'm sorry, Doctor. After the instruction executed in the physical hardware, so what is the
Yeah.
action after that? Number 7, what will happen?
Yeah, so once the instruction is executed in the hardware, the KMO will pick it. This is the KMO, will pick it and then send it back to the share page in the step number 7. Yeah, it would simply put the instruction in the shared page and then send a notification to the KVM trap code that I just placed the instruction in the share page. Can you please pick it? So the KVM will now pick the instruction in step 8 from the shared page and then send it in step 9 to the device driver, which in turn send it to the virtual machine that you created. Then you will now see the output of your program showing.
Yes. Okay, Doctor, clear.
So this is the default settings for KVM input-output process, default settings. We have another settings called veto. In the veto setting, the instruction do not go to the trap code. No. It uses what is called front end and back end. The front end is in the device driver, while the back end is in the KMO. So when you send an instruction from the VM simply send it to the front end, and the front end send it to what is called a V-ring. A V-ring acts similar to a shared page, okay? We don't have a shared page in this case, so it acts similar to a shared page. Simply send the instruction to the KMO. The KMO receive it in the back end, okay? And then send it to the device driver, which in turn send it to the physical machine. The physical machine will execute the instruction and send it back to the KMO, okay? So the KMO backend receive the instruction and send it through the VRing to the guest operating system. Okay? The front end driver of the guest operating system receive the instruction and give it back to your virtual machine, and then you see the output of your program will show. In any way, it's important to mention that notification goes directly from front end to back end. So anytime they send instruction to the VRing, the front end will notify the back end that I have sent an instruction to the VRing. Can you please pick it? So the KMO VRing backend simply picks the information from VRing and then pass it forward. This is the basic idea. So the main differences between the default, okay, and the virtual is that in the virtual, we actually do not have a share page. Instead, we have a VRing, okay? And the trap code do not pick information from the guest operating system. No, it doesn't. Rather, the information go to the VRing, and the VRing simply send it to KMO, and from KMO, the device driver and the physical machine. This is the thing. The last aspect is the introduction to fusion compute. So fusion compute is the Huawei's version of VMM or hypervisor, because different companies now have Oracle VirtualBox, we have the VMware by another company, we have the KVM, which works with the Linux, we have the Zen. So Huawei decided to create their own fusion compute. Fusion compute works on the idea of resource pooling. Okay, so we have virtual resources. That's basically your CPU resources, your memory resources, and your input-output resources. Okay, they are stationed in one place, and we have what is called virtual resource monitor or manager. Okay, VRM. The VRM is the Huawei's virtual resource manager that manages these resources. And then we have cluster of hardwares. Okay, so all the resources are residing on the hardware, and the VRM, virtual resource pooling or virtual resource manager, is the one that manages these resources based on request. Okay, this technology or this architecture is very good for scalability. Okay, you can request for little or you can request for more depending on the type of resources or the need for the resources, basically. So you can scale up and you can scale down the resources. So you have all the resources, you can scale up and you can scale down. This is the basic example for this is what happened in the AWS. Okay, also you have pool of resources in AWS, Amazon Web Services, and then you can scale up and you can scale down based on demand, basically. So fusion compute have some advantages, okay? Some of the advantages are unified management of virtual physical resources. So this is one of the important advantages. And quick virtual machine provisioning. Provisioning means that if it's requested, they can easily assign the virtual machines. Provisioning or allocation, similar, or sometimes it's called scheduling. These words are used interchangeably in most cases, okay? So provisioning of virtual machines is very easy using the fusion compute. This is another very good advantage. Yeah. I also forgot to mention there's what is called CNA. CNA, if I go back a little, yeah, so this is also called the CNA in the cluster. This is one of the technologies used in the fusion compute architecture. So the advantages or functions of the CNA include it provides virtual computing functions, it manages virtual machines on compute nodes, and also it manages compute storage and network resources on compute nodes. These are the functions of the CNA. While the function of the VRM, we already mentioned what a VRM is virtual resource manager in the fusion compute. The advantages or functions of it are it manages block storage resources in clusters and manages network resources, IP addresses, VLANs in clusters, and assign IP addresses to VMs. And also, it helps in the life cycle of virtual machine clusters, allocations, and migration of virtual machines, which we explained. You can migrate actually virtual machines from one physical machine to another. So it's easy because it is independent of the physical machine where it's being created. Also, dynamically resource scheduling schedules resources to different clusters and then manages virtual machine resources. So these are some of the important functions of the VRM in Fusion Compute. So that's the end of the slides. I hope you enjoy it.
Thank you, Doctor.
Hello?
Do we have to answer this question now?
Yes, let's try it. Question number one. In compute visualization, which of the following allocates CPU and memory resources to the VMs?
VMM.
VMM? Who wants to try again?
I think hypervisor.
Which one is correct?
C, I think.
Hypervisor.
No.
Let me read
Isn't
the
it the
question
host OS?
again.
In compute visualization, which of the following allocates CPU and memory resources to virtual machines?
Isn't it the host OS? Because it allocates to the VM.
No. You are far away from it.
Guest OS?
So guess us.
Guest OS is also far, far away from it.
I am okay.
Now you stop guessing. Anyway, I'm just joking. So the answer is B and C. Virtual machines manager and hypervisor. They mean the same thing actually.
Yeah.
So in Huawei, if you are writing their exams, you cannot score half of the score. This is a multiple choice question, multiple answer question. You have to take the two correct answers to get the score. Okay? If you take B and you did not take C, you fail. If you take C and you did not take B, you fail. Okay? You have to take both. It's a multiple answer question. So B and C are the correct thing. And throughout my lectures today, I keep mentioning that virtual machine monitor and hypervisor are the same thing. The same thing. There's no difference. There's no difference. So number two, all open source visualization technologies are type 1 visualization, while all closed source ones are type 2 visualization. True or false? To help us to answer this, false. I think we can go to the slides to understand it better. Yeah. Yeah, this is the open source. We have KVM and we have Zen. And they say that these two are type 2. Is it true? Let's go to type 2. Okay. Yes, KVM is type 2, but Zen is not type 2 actually. Zen is what? Type 1. So the answer is false. Muhammad is right. The answer is false. It is only false because Zen is not type 1. Zen is not type 2. It's type 1, while KVM is type 2 and not type 1. So you cannot put the two in the same sentence and say all of them are closed. No, they are not closed. One is open, the other one is closed. Yes. So these are the two answers. Yeah, so the remaining things is the summary of the slides, additional resources if you want to check and get additional information and start preparing for your CNA cloud certification for Huawei. Yes. Okay, wassalam.